So this story is very important, very basic, very commonsensical. Now there are multiple stories that I use as a mental model to understand the reality of today's AI, modern AI world, and also to maybe sometimes predict the future. But this story I heard from this gentleman, Jensen Huang, the CEO of Nvidia. Geoffrey Hinton, as we know, is the godfather of AI. He was the one who invented convolutional neural networks, the deep neural networks, and the idea of backpropagation. Hi everyone. So we are here to discuss a story. There's a very famous guy we all know, Jensen Huang, the CEO of Nvidia, the $1 trillion company, one of the fastest company to reach $1 billion mark. So when he speaks, we should listen. So he told a story. He narrated a story on one of the podcasts that I was tuned into. So the story goes, back in Toronto. So there's a university which is University of Toronto, and this very famous researcher named Geoffrey Hinton. So this Geoffrey guy is also the godfather of AI. He invented the idea of backpropagation. He also invented a lot more ideas with two very famous guys known as Ilias and Alex. Alex is the founder of AlexNet. Then Ilias was one of the co-founders of OpenAI. He now runs Safe Superintelligence, his own company. So this Geoffrey guy, the godfather of AI, this professor is also a recipient of Turing Award, along with Jan LeCun, who is the chief scientist of Meta. So he invented the idea of backpropagation. So when these guys speak and when these guys, curate something, I think people like us should listen. What he invented is a very key idea, very strong idea. I mean, for people who are new to this channel, they can think about this idea as he invented the way that machines learn today. The methodology with which machines learn was invented by him. So just to summarize, for our non-technical audience, so backpropagation is the idea of learning. Just imagine a giant neural network. A neural network has a lot of neurons. Those neurons can be considered as maybe a mathematical unit on a switchboard. This mathematical unit on a switchboard fires up or fires down. So why we call it a switchboard? Because we want to visualize a very complex, hierarchy or stacks of these units. If I want the switchboard to take in an input image of a cat and recognize that this is a cat, it is going to see a lot of input images of a cat before it recognizes it correctly. So the first sample that I show to this switchboard, the giant switchboard of mathematical units, it is going to predict maybe something garbage. If I want this switchboard to go and correct itself, maybe change its mathematical units up and down, let's say the switchboard knows 4 things: cat, dog, elephant and tiger. If the switchboard is recognizing the cat as a dog, I want it to go and correct itself. Silent all the neurons or units that say dog, tiger and elephant, and only keep up the neurons that say cat, right? And in this process, I will feed it or I will show it thousands and thousands or maybe hundreds of millions of images of cats and hundreds of millions of images of dogs. And it is going to go and correct all of its units on the switchboard that fire cat when they see a cat. And it's also going to correct all the units that fire dog when they see a dog. Similarly, they will keep on tuning their mathematical units up and down so that the switchboard can one day predict cat nicely. So this was the idea of backpropagation, which was, which is explained now in neural networks. So this was the invention of Geoffrey Hinton's lab. Now they were also working on convolutional neural networks to recognize images. They were also working on the larger charter of deep learning. They also coined the term universal function approximators. They called neural networks as universal function approximators. What they meant by that is the neural network can go see anything as input and produce something as output. So anything that can be fed as the input and produced as the output can be solved by deep learning. This was the overall abstract philosophy, that deep learning can solve anything with an input and which requires an output. It can approximate anything, it can predict anything, it can solve any modality, because it produces an internal representation that can be learned by these mathematical switchboard. So this was the kind of fundamental principles that they invented. So backpropagation was one of the key pillars. Then obviously they did a lot more invention in computer vision. So one of the most fundamental application was in images at that time. Back then, I think it's 2012, when they told that image recognition, if we solve image recognition, all the radiologists in the US and in Canada will be out of business. So that is what they predicted. Once we solve radiology using image recognition, using these, deep neural networks, the radiologists would go out of job and they would have no job. We might believe that the radiologists might have gone out of job, right? So we saw that when these neural networks and systems got into production, we were genuinely able to solve the task of a radiologist. The radiologist could study the images far better, with better precision, with much more edge cases, and they could study more of it. So the productivity of the overall system increased. The radiologist could test more patients. We also realized fundamentally that the purpose of a radiologist or the purpose of a job of a radiologist was not only to see images, it was also to diagnose the patient. The fundamental task was to see the images. One of the fundamental tasks was to observe the images, to see the images. But the overall purpose of a job of a radiologist was to diagnose the patient. So all in all, the hospitals observed that the radiologist can now see more and more images. We can cater to more and more patients. We can cater to more and more patients faster. The economics of the whole system improved better, and hence the hospital could afford to hire more radiologists. So we observed that this image recognition application in radiology did not throw all the radiologists out of job. In fact, the hospitals that could deploy these image recognition models nicely, they ended up increasing the productivity of their system, and they hired more radiologists because they had more money, because it led to better economics. Whenever you improve the productivity of a system, it becomes more productive. The return over asset becomes way more higher, and you have better cash flow, and you are able to serve more patients, so you might need more radiologists because the demand was naturally high, and you have now more precision, better judgment, and faster diagnosis for a patient, right? So you increased the productivity of a system multidimensionally, and hence you might want more radiologists. Now Elon Musk is also working on the machines that make the machines. He's also working on robots, right? He's building factories. He likes to call it the gigafactory, where he's trying to build the robots that can further build the robots, right? So it's like the AI that can build the AI, right? So when those robots go out in production as consumer robots, it is going to give rise to a whole new industry. Now that new industry will be a consumer robotics industry. We can surely imagine that there would come a company, a streetwear robotic company, that would manufacture apparels for these robots, because I would want my robot to look different than your robot if we both have robots, right? So we would see a whole new industry that would manufacture these robots, that would maintain these robots, put algorithms in these robots, maybe manufacture clothes and apparels for these robots, right? Now one more example. If the self-driving cars get productionized at scale in India, will all the chauffeurs be out of jobs? A lot of chauffeurs will be out of job, but there are some chauffeurs who are there in the job because of their hospitality, because of their ability to serve the car owner, because of their ability to secure the car owner, because of their ability to secure the car sometimes in a complex environment. Do you think those chauffeurs would be out of job? No. Some chauffeurs would change the industry. Some chauffeurs would still be chauffeurs and they will not be out of job, and some chauffeurs will be out of job. So the key insight that we can learn from history is, if the productivity of the system improves, if we have the ability to ship faster, the job might evolve. But if your job is the task, for example, if you are a radiologist that can only see an image and interpret an image without producing any diagnosis, then you will be out of job. If your job itself is the automation, if your job is equal to the task, then you will be out of job. But if your job is beyond than the task, if your job is a collection of tasks along with layers and layers of human opinion and human judgment, you will not be out of job. So the fundamental key takeaway here is, if our job is equal to the task and that's it is that plain vanilla, we will be out of job. But if we can figure out, or if our job is already beyond the task, we will not be out of job, and we might be able to leverage the overall increased productivity and the increased economics of the system. Thank you.